So now I want to pivot to neural networks. So this is the foundation of modern AI. It's especially the AI that you think of when you think of ChatGPT and the stuff that's really on the cutting edge, doing really powerful things today. This really is centered around the neural networks. Now, neural networks they often use machine learning to train them. So these things are not mutual exclusives. But neural networks are what we use in facial recognition. They're what we use in all of our large language models are neural networks. And so they do really powerful things. So they're inspired by biological neural networks. And the idea is that, very crudely speaking, we represent neurons and the way they connect to each other. Now, biological neurons, neurology is way more complicated and nuanced than what we do in the computing world. But the idea is there. The idea is that as we create these big networks of interconnected neurons, we get these emergent behaviors that can resemble intelligence, that can identify things, make predictions. So pattern recognition through layered processing. That would be your good takeaway for what we're trying to do with a neural network. So, and this is a big topic. So if everything doesn't click right away, just know that that's okay. This stuff is like, it's hard to wrap your brain around. And so I'm trying to break it down with this analogy of a committee. Okay. So I want you to think about this as a voting committee. Now, it's an interesting voting committee. They have some interesting rules for how votes count and how the votes count change over time. But we have several layers. So we have an input layer and an output layer, and we can have as many hidden layers as we want. In fact, your large language models have so many hidden layers, but we could just have one or two. And so in this example, here's a basic neural network. Our input layer, leaning on this committee analogy, these are our junior members. They all have equal votes. So every junior member's vote counts equally. Analyzing the very key features. In this case, we're analyzing the key features of an image. So I'm going to feed an image to this first committee, and they start to define like what we think of as the like visual like design elements of the image. So they find the edges, the corners, the lines, and the curves. And then they basically vote, this is an edge, this is a line, this is a curve, etc. Then they feed that to the next layer. These are like our specialists who are able to combine some of these elements together. Edges, curves, lines, to begin to make predictions about what kind of texture is there. What shape is there? Is it circular? Is it square? Is it concave, convex? And the relative size of things. And then they might feed those, so they vote on what they see, and they feed that to yet another layer that's even more abstracting. It's making even higher level recognition of the patterns it sees. And then that final layer, these are like your kind of senior members who take all the evidence into account, and they make their final decision that they vote on what they're looking at. Probably a dog, could be a cat, maybe even a bird, but not very likely. That's kind of how an image recognition neural network would work. Here's a more detailed kind of breakdown that I think will help clarify this a little bit. So you can see at the beginning, the neural network is just identifying the very basic properties of an image. And then the next layer is able to build off of those and begin to kind of build up, find repeating patterns, find textures and shapes, and then feeds that in. And now this layer, they start to recognize eyes, ears, legs, tails, right? Or wheels or windows. And then that last layer can kind of put together what is the object based on these elements, right? Is it a cat? Is it a tree? And so this is kind of how we create neural networks that do image recognition. And now let's talk about like the idea of voting. So we can see this first, this edge detector. This is one of our committee members at the input layer. And their vote weight counts 0.7%. And they say, I see curved edges that look like fur patterns, right? So that's their vote on the edge, okay? And then our shape builder, we can see their vote counts a little bit more. Why? Well, probably over time, they've shown to give the judgments that when we do machine learning, to basically say, okay, neural network, check your work. This was a dog, or actually this was a cat. This shape builder's predictions were accurate. It made the predictions that helped the judge determine that, yes, this is a dog when it actually was, and yes, this is a cat when it actually was, right? And so over time, this committee member's vote came to count for a little bit more than this one, right? And this one may be similar weight, but maybe its expertise sometimes was overconfident. And so from all these training cycles, when it gets it right, we subtract a little bit of weight from the parts of the neural network that didn't perform well, and we give a little bit more voting weight to the part of the network that did perform well in making an accurate prediction. And even specific members might have stronger weights than others if they are the helpful ones in getting the right answers. And so over time, we developed this neural network where the voting weights are kind of based on how important they are to determining to voting on the right decision. And so what we get is this prediction, right? And now the same technology is actually what is responding to you when you do a chat with ChatGPT or Gemini. So even though it feels like you're just talking with a person who understands you, it's actually this technology, this neural network that's literally predicting the most likely words to output to you, which is really fascinating and baffling to think about. And it really gets into the idea that when you have a big enough neural network, like millions of connections, then you get emergent intelligence. So it may not have like self-awareness or anything, but there's this emergent ability to kind of recognize and understand natural language. So we start at the simplest level, we have a neuron, and then we have layers of those. They build up our networks. And a deep network is really what we're talking about is just, well, think of literally this with more depth, right? Think of, instead of like 4 of these in hidden layer 1, think of it spanning like 1,000 of these, right? And then think about it being deep. So there are like tons of these hidden layers. That's all we're meaning when we say deep networks. And so deep networks, that parts of the network, and this is what we see with what we call multimodal large language models, parts of the network are useful for different things. Part of it is good for responding to you with good, sensible grammar. Part of it is good for modulating its tone and conciseness, maybe. Part of it is good at recognizing images. And part of it is good for tasks like coding or maybe even helping do math problems.